To this video in our course Competition Policy and Strategy. In this video we are going to cover the solutions to exercise 5.3 on the topic of contestable markets. Alright, now let's first understand the setting in this exercise. In this exercise we are going to assume that there are two firms and these two firms can both produce a homogeneous good. We also know that both firms are facing the same demand function. Q as a function of price equals 100 minus price. All right. Yes. What we also know is that both firms produce at a constant marginal cost of C equal 10. And that both firms incur capital F fixed costs, which is set to a value of 1001 in this exercise. Furthermore, we are going to assume that firms do not face any capacity constraints. All right. Now let's sketch how this competition is supposed to work in this exercise. We are going to assume that there is one of those firms that is already active in the market, and we are going to call this firm the incumbent firm, or capital I. This capital I firm, this incumbent, starts by setting some price P with an index I. And only after that, the entrant firm, that we will call capital E, chooses whether it wants to enter the market or not. And in case it enters the market, on what price, P with an index E for entrant, it wants to set. All right, and then after that, so after both firms have decided on their strategy, PI or PE respectively, well, then we will look at the market equilibrium, or how we phrase it down here is subsequently demand is realized, which is another way of saying, let's have a look at the market result. Let's have a look at the at the result that arises from these strategies both firms chose. All right, let's start with task A. In task A, we are going to assume that the fixed costs are not sunk. So this is needed in order to say that the market is a contestable market, in the sense that there is no additional costs of an entrant, of a firm that is not yet in the market, to enter the market. Okay, no additional costs in comparison to the incumbent, so in comparison to the firm that already is active in the market. And then we are asked to answer the question, what price will result in equilibrium, and describe why this particular equilibrium results. All right. Now, in the following, I will differentiate between a so-called case 1 and a case 2. Why does this make sense? Well, let me start by sketching what this game would conceptually look like. All right. So conceptually, we have, as we have described in the exercise task, we have a player I, and this player I, in the first stage of the game, chooses between two options, two feasible options. One option would be to set a price, PI, which is larger than the average costs. All right? And the other option, or the other case, would be to set a price P with an index I equal to the average costs. This, of course, is equivalent to saying, well, the incumbent can either choose to set a price which yields in positive profits, or, and that's the second case, to set a price with which yields zero profits. Which is precisely why we are why we are limiting this game to these two options, because of course theoretically there would be a third option, which would be to set a price that was lower than the average costs, but of course that would result in negative profits and thus would never be a profit maximizing strategy. So we can just discard this for now and limit ourselves to these two options, which we will refer to in the following as case 1 and case 2. Case 1, namely setting a price Pi that is larger than the average costs. Alright, let's start with case 1. Conceptually, going back to the tree, we are now on this left-hand side. So player I, the incumbent, chose to set a price larger than the average costs, and now player E, the entrant, has to make their decision. And player E, the entrant, again has two options. So this is where player E is choosing their strategy in this sequential game. Now player E, again similar to player I, has two feasible options, and the feasible options are, well, player E can enter the market and set a price which is below the incumbent's price, so PE equals Pi minus epsilon, or alternatively, the entrant can decide to not enter the market at all. All right, so that would be the second option over here. All right, so we will call these two options entering and not entering in the following. Let's call this entering and not entering in the following. All right, so let's now consider, or let's just take a step back and look at this sequential game. As we have already discussed, we are looking at the left-hand side of this game, so we are for now considering a situation where the incumbent is choosing a price Pi which is larger than the average costs, so this left half of the game. And now we need to consider these two scenarios, namely the first scenario being the scenario where the entrant actually chooses to enter the market, and the second option would be that the entrant chooses to not enter the market after all. All right, so let's start with the entrant E deciding to enter the market. And as I have already indicated previously or earlier, this implies if the entrant decides to enter the market, that they set a price PE which is at least marginally lower than the price of Pi, the price of the incumbent. So this would mean we would observe a price PE which is equal to price Pi minus some epsilon. All right, now because we have assumed that both firms are offering a homogeneous good and neither firm is limited by any kind of capacity constraints, this, of course, similar to what we have seen in the bear draw, or what we know from bear draw competition, this would imply that firm E is serving the whole demand. All right? So firm I is not selling a single product, simply because firm E undercut their price. In this setting, that would mean that firm I, the incumbent, would sell not a single good and would therefore face negative profits in the amount of minus F. All right, so let's write down the profits of firm I in this case would be minus F, because it's not selling a single unit of its good, but at the same time it is incurring the fixed costs per assumption. At the same time, what are the profits of firm E? Well, firm E, as we assumed, undercuts firm I, so setting a marginally lower price, which by assumption, because E's epsilon is really, really small, is still larger than the average cost of both firms. So firm E is able to extract positive profits from this market. Okay? Whatever the amount is, does not really matter for this application, but what we know is, well, if Pi is larger than the average costs, then there is still some wiggle room for the entrant E to slightly, ever so slightly undercut I and still have price larger than average costs and thereby making positive profits. So in the equilibrium or in the result of this strategy combination, we see positive profits for the entrant. Okay. Now to the second option of the entrant, right? We have now found, we have previously found that what is the market result in case player I chooses to set this price larger than the average costs and player E choosing to enter the market. Now the alternative for player E would be to not enter the market. And in this setting, the results probably are even more or are more intuitive to understand. Because if player E does not enter the market, well, that implies they do not undercut player I's prices, right? So player I is actually making a positive profit from selling their goods. Not being undercut, they can serve the demand. So that's what we see over here. At the same time, if player E simply does not enter the market, well, they don't incur any costs, not even fixed costs. They are not even active in the market, right? So the profits of firm E are simply equal to 0 in this scenario. Okay? And by this, we have now found the payoffs or the profits for all strategy combinations in this left-hand side, in this left part of the game tree, of this decision tree. All right? And just to summarize, what we see in this left-hand side at least is that a market entry is the profitable option for the entrant in case the incumbent chooses to set a price that is above the average costs, right? Just as a brief reminder on how to analyze this kind of games, of course, keyword backwards induction, right? Player E, being the one that chooses second, can observe the strategies player I chose. So player E knows that they are at this point in the decision tree. Player E knows the results of the game for all possible options, so for entering and not entering. So player E can now compare their profit for entering the market, which is positive, with their profit for not entering the market, which is 0. So of course it is profit maximizing for the entrant to enter the market. All right, and that is what is written down here. Market entry in this case is profitable for the entrant. All right. This, of course, is only half of the story that we need to tell in order to find the equilibrium in this sequential game, in order to find the equilibrium results in this sequential game. We, of course, in the next step have to consider case 2, namely the case in which the incumbent does not choose to set a price larger than average cost, but instead set a price equal to the average cost of production. And that is what we are going to do on this slide. All right. So, yeah, this needs to go. All right. So, similar to what we just did, we are now analyzing the profits of both firms for this part of the decision tree. So, in the first stage of the game, the incumbent chooses to set a price equal to the average costs. So I chooses PI such that PI equals average costs. Yeah, all right. After that, player E, let's for a second skip these 3 bullet points and let's first talk about what player E is doing before coming back to the actual market result. All right. So in response, now player E is considering what is their best response to this strategy. And again, player E can either enter the market by slightly undercutting or not enter the market and therefore not undercutting the price, technically setting no price at all, and simply letting the market equilibrium realize as is. All right. So let's, in order to find out what is the profit maximizing strategy for E, so which of these two strategies is actually the one that yields the larger profit, we first need to understand what the market equilibrium looks like in case the incumbent chooses a price equal to the average costs. All right. So let's find the actual equilibrium prices that would result in case this is the strategy that is played. So what is the actual price Pi that results in case this strategy is chosen? Well, if we know that Pi equals average costs, we can of course calculate Pi simply by stating the average costs in this market. Okay, so what we have here is Pi or price as it results from the demand function, and we know that this price needs to be equal to the average costs. Now, solving this equation, Pi equal to AC for Q, simply because it's quadratic in Q, yields two solutions. There's two candidates for solutions in this setting. The first one would be a price of 23, and this of course implies a quantity of 77, and the second one would be a price of 87 and a quantity of 13. Now, which of these two possible candidates for the price is the one that actually would be observed in the market? Because we can exclude one of them actually. Just think about it for a minute. We need to set one price that is equal to the average costs. And we know that in this market, slightly undercutting your competitor's price will result in serving the whole market and realizing a market share of 100%, right? So we can, based on these assumptions, we can exclude this second candidate where the price is 87, because we can undercut these prices, set lower prices, and thereby, for example, set a price equal to 23, and thereby set a price which is equal to average costs, right? But so still yields non-negative profits, but at the same time is lower than the other one, right? So 23 is lower than 87. So the only price that actually marks an equilibrium in this scenario is the first one we offered, which was this one up here, where the price is 23 and the quantity is 77, and we can discard the second candidate. All right, so in this case, case 2, where the incumbent sets a price equal to their average costs, we now know that the actual price that is set by the incumbent is equal to 23. Now, based on this, the entrant can decide whether or not to enter the market. And entering the market, again, as in the previous exercises, would imply that the entrant would undercut the price of the incumbent, set a price which equals, or which is PE equals to PI minus some epsilon, which importantly implies PE is smaller than PI, which is equal to the average costs, right? So in case the entrant actually decides to enter the market and sets this price, well, they would set a price that is lower than the average costs and therefore make negative profits. All right, so entering the market implies this over here, which in turn implies pi e smaller 0. All right. Of course, because the entrant enters the market and undercuts the incumbent also realizes or faces negative profits, right? Namely, pi I equals minus f, which of course also is smaller than 0. Okay, so much for the first option of the entrant. Now towards the second option of the entrant. Of course, the entrant can also decide to simply not enter the market at all, which yields a profit equal to 0 for the entrant. And not only for the entrant, but instead, because the incumbent is setting a price equal to their average costs, we see that the incumbent as well gets 0 profits. So in this equilibrium, we know that both pi E as well as pi I equals 0. All right? And now, similar to what we did earlier in the left-hand side of the decision tree, let's have a look, or let's think of what will be the profit maximizing strategy of E, of the entrant in this situation. Well, the entrant observes the decision of the incumbent and then decides on whether or not to enter the market according to their profits that they realize in each of these scenarios. So the entrant is now comparing entering the market and getting negative profits to not entering the market and making 0 profits. And then of course it's easy to see that not entering the market and making 0 profits is the profit maximizing option between these two, right? Because 0 profits is still better than negative profits. And now, with this we can then find our equilibrium. Because, let's have a quick sketch of our decision tree once again. We have some price PE that is larger than average costs. On the left-hand side, on the right-hand side, we said we have some price of the incumbent which is equal to the average costs. All right. Then we said the left choice of the entrant is to enter the market. The right-hand choice was always to not enter the market. And then we have figured out that in case the incumbent chooses a price that is larger than the average costs, it would actually be profit maximizing for the entrant to enter the market. And in this case, the incumbent made negative profits of minus f. This is just repeating and summarizing what the results that we have found through this whole exercise. And then on the right-hand side, so case 2, what we were just analyzing, in the case the incumbent sets a price equal to the average costs, we found out that not entering the market yields 0 profits for the entrant. So it was the profit maximizing strategy, the best answer of the entrant in this scenario. And just as a reminder, we also calculated that in this scenario, the incumbent makes 0 profits. Okay? So how do we now find the equilibrium in this scenario? Well, in this sequential game, which we are now solving by backwards induction, we have now found the best answers of the entrant, or the second player, at each node. All right, so now we can move one stage up in the game. And one stage up, of course, means to analyze what is the profit maximizing strategy of the first moving player, player I, or the incumbent. The incumbent, again, has to decide whether or not to set a price that is larger than the average costs, with the alternative being setting a price that is equal to the average costs. And now, anticipating the answers of the entrant towards these strategies, the incumbent can already, consider the payoffs they will get for each of these two alternatives. All right, because in case the incumbent chooses to set a price that is larger than the average cost, they already know that the entrant will enter the market and that their profits in the end, so that the incumbent's profits in the end will be minus capital F. And in the second case, so in case the incumbent chooses to actually set a price equal to the average cost in the first place, they can already anticipate that the entrant will not enter the market and that they will, in the end, make zero profits, pi I equals 0. Now, comparing these two final results, comparing these two options, they will of course come to the conclusion that zero profits are still better than negative profits. So the incumbent will come to the final result that setting a price pi equal to the average costs is the profit maximizing strategy. And with that, even though the incumbent is the sole firm in the market and will not even get a competitor in the second stage, they're still making zero profits, which is the interesting and striking result of this model. All right? To summarize, in equilibrium, what we see is no market entry of the entrant and a price pi equal to the average costs up here. All right? So the threat of market entry of the entrant is what prevents the incumbent to exploit their market power. That's why we call it a contestable market, right? What this second sentence, this one up here, summarizes what we have just analyzed. Namely, the incumbent cannot exercise their market power and set a price that actually yields positive profits, because if they did, if they would do so, then the entrant would enter the market, undercut them, and steal the whole market from the incumbent. All right? So the threat of the entrant entering the market is sufficient to prevent the incumbent from exercising their market power. At the same time, this is the first striking result, that even though there's only one single firm in the market, we see a price equal to the average cost and zero economic profits in market equilibrium. At the same time, we also see that there will only be one firm in the market, right? So we at the same time prevent, or we at the same time do not see doubled fixed costs. Because the incumbent is setting price equal to the average costs in the first place, well, the entrant will not enter the market in the second stage. So we only have one firm in the market, which is causing fixed costs only once, right, instead of twice. And at the same time, we see a market result that we would expect under competition, even though only one firm will result in the market. All right. We will now make a slight change to the model, and that is that we will from now on assume that the entrant will incur an additional sunk costs of S equal to 124 in the case it enters the market, right? So the incumbent only faces capital F if they produce and if they are active in the market, which they are by assumption. The entrant, however, incurs an additional sunk costs, which is of course, in this model treated in the same way as the fixed cost capital F. So if the entrant E decides to enter the market, they will not only fix the fixed costs of 1001 that the incumbent also faces, but in addition they will face this one-time fixed sunk costs of 124. Now, how does this change the market equilibrium in this contestable market? The starting point of this solution is that it is no longer true that the average costs of firm I is the same as the average costs of firm E, right? The entrant does no longer have the same average costs as the incumbent, simply because the entrant, of course, is now facing fixed costs as well as sunk costs. All right. So we need to keep this in mind. So the incumbent can, so to speak, make use of this. They can, in the first stage, they can now choose to set a price equal to the average costs of the entrant instead of their own average costs. Which means that in equilibrium, or in this decision tree which we were describing earlier, Pi equals ACE now, this means that still for the entrant entering the game, entering the market, still results in negative profits, right? So, because the entrant would have to set a price in case the entrant enters, the price of the entrant would be PE equal to Pi minus some epsilon. That of course means they would have to set a price which is equal to their own average costs minus some epsilon. So this of course implies that in case the entrant enters the market and sets this price PE, they would face negative profits. All right. So from the viewpoint of the entrant, the payoffs do not change at all, right? It's still the same game from the viewpoint of the entrant. The only difference being that, of course, if the incumbent sets a price that is equal to the entrant's average costs, rather to equal to their own average costs, and of course, given that the average costs of the entrant are larger than the average costs of the entrant, well, the result of this strategy is that the incumbent is now making positive profits, right? Positive profits that arise precisely from this difference in average costs between the incumbent and the entrant. All right, so similar to what we saw earlier, right? We still face the same equilibrium. If you were to sketch the whole game and analyze the whole game, you will find that we still see the same equilibrium, in which the incumbent sets a price equal to the average costs, the entrant's average costs that is, in order to prevent the entrant from entering the market. All right. At the same time, and we can of course calculate the price and the quantity that result in this situation. However, what we can see based on this equilibrium, so price equals 25, quantity equals 75, what we can see in this scenario is that the profits of the incumbent are no longer zero. All right? And now in task C, we are going to analyze or to interpret these results that we just saw. Right? Interpret these results, in particular address the market power that accrues to the monopolistic incumbent. Also discuss the practical relevance of the concept, which is something that we will do in the end of this task. All right? Let's first start by interpreting the results. So this is basically just a summary and a reiteration, a recap of what I just lined out based on the game decision tree, based on the payoffs that we see in the game. Okay? So, in the previous case, in task A, this is referring to task A, we saw a situation where both firms had average costs in the same height. And in this situation, just to reiterate, we saw that the incumbent prevents market entry of the entrant by setting a price equal to both firms' average costs, which then resulted in a situation where both firms make zero profits, or rather, technically speaking, the incumbent makes zero profits and the entrant is not even active in the market, okay, which of course yields the same. Now, now in the situation where now in this situation down here, there's task B. Now in the situation where E is facing these additional fixed costs, or which we furthermore defined to be sunk costs, this means that the incumbent gains market power. And now this sounds like quite much, but just remember how we defined market power last week. We said that market power means a situation in which a firm in a market can set a price that yields a positive profit margin, right? That's it, that's all. So we can say that in this case where the entrant now faces these additional fixed costs that are sunk in case they decide to enter the market, this provides market power to the incumbent because they can now set a price that is ever so slightly, or by the difference on these fixed costs, larger than their own average costs, and thereby gain a positive profit margin. All right. All this shows, or all this can be used to show that sunk costs of entering a market can be, or that sunk costs can cause a barrier to enter a market. Right? Just as we saw in this exercise, facing these additional sunk costs can deter an entrant firm from entering the market actually. Right? So even though there is positive profits in the market, and throughout this whole semester so far, we always face situations where we could say, as long as there is non-zero profits, as long as there is positive profits in the market, we would expect market entry. Well, now we have a model at hand that shows that this is not necessarily true, right? Because there can be barriers to entry, and sunk costs is one example of these barriers to entry. And these barriers to entry can provide the incumbent firm or firms with market power. And in this case, what we were also showing is that barriers to entry can even go so far as to facilitate the existence of a monopoly. All right, now, what are examples of barriers to enter or of these sunk costs? Well, one example would be high cost of advertisements or cost of research and development. Advertisement, let's just dive a little deeper into this. Just consider a situation where there's firms that have a particularly high brand recognition, that are already in the market, and that through this enjoy a certain degree of market power. Well, now a new entrant firm, a new competitor, would have to bear these high costs or even high sunk costs in order to get a similar brand recognition, in order to enter the market, in order to compete in this market. All right. This is particularly important, and we will have a look at examples of the following in network industries. So in markets where we have network effects. Why is it particularly important in this case? Well, network effects simply mean that there is even positive external effects of consumers onto the utility of other consumers, basically, right? So firms, in a nutshell, firms have an advantage if they have a broad user base, all right? And now, if you consider a situation where both of these phenomena collide, where both of these are true at the same time, so we have something like large advertisement costs or even login costs or anything like this for the consumers, and there is network industries, where in these cases we will see that these barriers to enter can be very substantial and very important to look at. All right. So, and one example of this of a market where both is important, so where there is network industries going on, as well as something like cost of advertisements and brand recognition, is, for example, messenger services. I think you all can probably come up with your own example of a messenger service which I think is a quite intuitive example on how to understand why it is important, how many other users are using a product, and at the same time that illustrates that getting the user base and the brand recognition can be very expensive for a new entrant into the market, and that the incumbents in the market are really experiencing or gaining market power simply due to effects such as the ones that we discussed in this exercise.